Welcome to Electronics Techie. So in this video we are going to discuss Verilog code like that. It is like gate level modeling. We have to build some of the gates, means we have to find out the output values of the logic gates what we have. So in gate level we already discussed in previous video what is gate level, what is structural, what is the behavioral, and what is the data flow. If you don't watch them, then go and watch them, then come back to this video, then you can understand very well. So until then it is a gate level modeling code. So in the we already discussed in gate level there is a primitives like that. So in gate level we have primitives. So in Verilog we have design code and as well, and another one is test bench code. So this is the design code. So next we have to write look into the test bench code. So in this design code, so how you start, you have to start with module. In Verilog language you have to start with module and end with end module, and whatever the you have to design the hardware, it will be inside the module and end module. So you have to simply write module and end module. So you can start with module, so it is M. Then you can write any module name. Gate, here I write gate underscore level. You can write gate underscore level underscore modeling. So you can write your name also, but why you represent a particular thing means you have to identify which type of code it means after some days later. So that's why you can represent any, but don't represent with keywords. So there is a inbuilt keywords in Verilog, so don't represent these module names with keywords. So until then you can use any name here. Then for suppose gates and gate, so what are the inputs for this? A and B are the inputs, and the here I consider end underscore output is the output of this AND gate. So here you simply write the inputs with input keyword. So if you write input keyword means they are the inputs only. So in C language you like int like that. So but they are the data types. Okay, it's another step. So until then in this when you write input, it is directly it says that the A and B are the inputs. So you can simply write input A comma B, and what is the output here, and underscore out. So in the same code I want to write all the logic gates output. So that's why I consider all the outputs of the gate, but the same inputs. These A and B are the inputs for again OR gate, but the output will be OR underscore out. I consider OR underscore out is my output of the OR gate. So same A and B are the inputs for NAND gate. So the output will be changed, NAND underscore out. I want to assign the NAND operation AB values to the NAND underscore out. So same AB values to the NOR gate. So like the NOR underscore out, the output of the NOR gate will be the NOR. So that's why I can consider different output ports here. So output means it represents all these are the outputs. So these are the outputs for every gate. So what we want to build, we have to know primitives. There are the inbuilt primitives in our Verilog code. So AND means it is a word keyword. It is if you write AND means it perform the AND operation between the variables what you give. So what is our process? First we have to write the primitive and then instance name. So you can write instance name what you want. So you can write your name, but anything you can want. So you can write any instance name here. So then what is our flow up means? First we have to write output follow with the inputs. So for NAND here you can see AND gate. So the NAND AND underscore output is our output. So wait, I change my color. So AND underscore out is our output. So A comma B are the inputs. For this here can consider this is the AND gate. So AND underscore output is output and A B are the inputs. So you can follow like this. So output followed by input. So same as for OR gate. OR gate output will be instance name, and the OR gate output will be the R underscore out comma inputs are A comma B. So here you can see NOT gate. So NOT gate symbol is, it seems like this. So only one input, one output. So here I consider A as the input, but you can take B also, whatever you want. So output will be the NOT underscore out. So output I represented with NOT underscore output variable. Output I represented with like this. So that's why I write output followed by input. So same as I can write all the gates. So how many gates are there? 4, 5, 6, 7. So the 7 gates here you can represent. So and with AND module. So it is like it seems like it is a gate level modeling, means you can represent everything in the gate level like that. So that's why it is a gate level modeling. So until now we see design bench. So now you can write the test bench here. So how you write the test bench means, so here also in test bench also you can start with AND module and end with AND module. So here module, you can write here also a module name what you want, and I can represent it with the gate underscore level underscore TB, but you can use any name. But the module name does not contain any space. So gate space level like that. So don't give spaces. So you can represent with the underscores. Don't use any special characters. There are also some rules that I can also share from upcoming videos. So until then you can represent with any module name. So don't use any special cases and start with numbers. Don't start with numbers like that. So next page. So what you have to do means, so you already discussed in the previous video what are the inputs we take. It will be the reg or netted data type, but whereas the output is only the netted data type. So for most of the Verilog codes we consider input as the reg, a comma b, and the wire. Output are the wire. So you can simply write the output ports you have to write. So what you have to do, so you have to connect these design code ports to the test bench code ports. So then what you have to do, they have the two ways for the port connections. So port connections are already two types. I already done a video on this. So if you don't watch, then go back to that video and then come back to this video, then you can understand very well. So one is by name and one is by position or by order. So some different names are there, position or order, we can say any name. So by name means we can connect like this. By position means you can simply whatever the order A, B, and whatever the order here, so you simply write the order. So here most of them are when you have more inputs and output ports, so you have to prefer name. Means by name we can represent anyway. So here I write A, but no need to write in starting position only, but you can write this A in last also. But when you represent it with position or order, you must represent A is in starting position only, because here in the design code it will A is in the starting position. So in test bench also you can represent in initial only. So it may be confusion while you have many input and output ports. So that's why you can mostly prefer the ports connection by name. So how you connect? So first you have to write a dot. It's represented like this. So next A. So whatever the design code variable here A, this A is connected to here this A. So we can simply represent the A. So no, I don't want to represent with the A. I can represent it with X, means it's up to your choice. Then what you have to write inside the bracket? So you can simply write the inside the bracket with X. So whatever the variables you take in the test bench, so you have to connect those values to this whatever the in the design code ports. So here we can connect these A with and test bench variable with the design code A. So same B is connected to B and out is connected, like that we can connect all ports of test bench to design code. Then your all ports will be connected, means till now you can give AB and the output. So if you think it is our test bench, so these A value will be what you want to give, 1 or 0, it will be connected by test bench. So whatever the output you can drive here, you can take from this output. So whatever the test bench do, so you can connect this port, means it is like this AB. So it is like test bench. So you want to give some value to A. So before you can't directly give these values. So you can connect, you can give, but if you want to change from particular time to time, so you have to write test benches. So you want to verify the truth table and the different combinations, you have to write test bench. So this B is connected to B. So what you do, you can give the different values to this inputs. So then you can verify the output by the output port. So these output is connected to the test bench output. So that's why you connect like this. So next we can start with initial begin. So these initial statement you have to write some statements which want you to display in the serial manner. So after these steps, this step will happen. After these two steps complete, this step. So whatever the initial, it will be the whatever inside the block of the initial block. So it will be the serial order. So whatever the initial, so if you have two initial blocks, it will be run parallelly, but inside the statements, whatever the statements inside the initial blocks, that will be display or performed in serial manner. So whatever the initial, if it is one statement you can simply write, but if it is multiple statements you can write begin and end. So this begin will end here by end keyword. So now we have to take any combination. So 0 0 means, so two variables A and B are the two variables. So how many combinations? 2 square means is nothing but 4 combinations. 0 0 0 1 1 0 1 1. So you can take different combinations here. So 0 0 for after 10. So /10 represent our delay. So after how much time you want to change your A and B values? So how much time after you want to change your A and B values? So it represented with delay. So A is equal 0, and so after 10 seconds you can change A and B values. So after 10 seconds again you can change A, B values. After 10 seconds you can represent what are the values of A and B. So you want to stop here, then you can, after 10 seconds you want to stop, so then you can simply represent it with dollar symbol, finish, and open and close the braces and semicolon. It represent you want to stop the simulation at the particular time. So if you don't write finish means the process will continue at the infinity level. So it is a taking our memory loss point. So if you want to cut them, so you don't need other step, then you can write this finish keyword simply. So and with end module finally. So it is our test bench. So after writing design code and the test bench code, you can verify your errors. If you find any errors like that, so you can cross check, or if whatever the errors you can read and understand and you try to solve. How many doubts you get, how many errors you get, how much depth into the subject you get. So don't worry if you get any errors. If you, while trying these, if you have any doubts, you can comment on it. If you have any errors you can't understand, then you can also send me the screenshot. Means if you say I want some doubt like that, you want to share any doubts, if you want any errors, then in my LinkedIn. So if you want, you can comment. I will post my LinkedIn link like that. So until then, it is our output. When after completion of 0 errors, like 0 warnings, then we get this waveform like this. So you can see that. So first 10 seconds the combination will be the 0 0. So here you can see A value is equal to 0 and the B value is equal to, so here it represented these yellow line. So whatever the values here, it can be represented these yellow lines. So you can adjust these yellow line to here, here, or here by clicking this on this scale. So for your better understanding, this yellow scale is represented in middle of these 10 nanoseconds to 20 nanoseconds. So I also explained this part. So then without confusion you can understand properly. So these are the A and B values. So A value is equal to 0 and B value is equal to 1. So 0 means it is like represented like this lowercase, and the 1 is represented with uppercase. So it is positive level and the negative level. So here AND gate output. So 0, you can consider 0 1 combination. So 0 1. So AND gate output, what will be the 0 1? 0 into 1 is nothing but so 0. So you get 0 here. So here you can connect these AND with NAND. So 0 means the NAND gate output will be 1. So here cross check. So NAND gate output will be 1. So it will be correct. So next OR gate. So the combination is 0 and 1. So OR gate means 0 plus 1 is nothing but 1. So you can check R value is 1. Okay. So XNOR is the invert of NOR gate. So you can get 0. So it is right. So next NOT gate. So what you get NOT gate? So A value, whatever the A value, you can invert of A, because you can consider the NOT gate input as A. So that A value is equal to 0. So NOT gate output will be inversion of A. So that is nothing but 1. So it is right. So next XOR. So 0 1 combination means it is unequal values. The output will be 1. So XOR and XNOR are inversion. So it will be 0. So by these waveforms you can understand like this. If you have any error, then cross check your port connections, means while you connecting the ports or while you giving values like that, you can cross check once, then again you can simulate. Then also if you get any errors, you can comment on this under comment section. So after that you can get schematic. How you get schematic means what is the internal connections we have to build, that will be represented in the schematic. So it is our schematic diagram. So now only A, B are the inputs for all the gates. What NAND gate, AND gate, OR gate. So whatever NOT gate, XOR, XNOR. So whatever the gates. So for all these gates, A, B are the inputs only. So that's why there are only 2 inputs will be represented here. So how many outputs here? 1, 2, 3, 4, 5, 6, 7. So you can see here are the 7 outputs you get. So internal connection is like this. So AB are the inputs for the AND gate. So again these AB are the inputs for OR gate. So again these are AB are the inputs for the XOR gate. So what you have to do? So if you directly take these gate output, it will be the AND underscore output. So if you give these AND gate to NOT gate, so AND plus NOT is nothing but NAND gate. Means you already know about this. In digital electronics you already learned that. So AND plus NOT is nothing but NAND gate. OR plus NOT gate is nothing but NOR gate. So it is a primitives. So what are the primitives, AND or not? You can use those primitives. Inbuiltly they can connect like this. So XOR plus NOT gate will be the XNOR gate. So like that we can get the schematic diagram. So thanks for watching. If you have any doubts, feel free to comment on it. I will definitely give reply to anything. If you want any other code also, you can comment. I also start coding from basic, but in between you are in any struggle like that, so you can ask me at any code, so I can solve it. I can clear your doubt as much as possible for my level best. So until then, bye.